This video is going to go over how we name and formula write for acids. To start, we're going to look at the general kind of table of rules here. So acid names are all based on kind of the second ending name, so the anion name, the negatively charged ion. If that name normally ends in "ide," which we find typically on the periodic table, we would change it to have a prefix and a suffix of hydro and ic. So my memory cue here is "ide," like hydraulics. If it normally ends in "ite," then we would change it to "ous." So this memory cue is Sprite is delicious. And then lastly, if it ends in "ate," also found on polyatomic ion sheet, this is I8 something ic. Or icky if we prefer. So officially, we're going to take some notes on the rules here. We have name to formula to start. So if you're looking at the name, the endings have already been changed. So you need to revert them back to figure out what the ion is. So if you're looking at an acid name and you see it ends in "ic" and also has hydro to start, that means the original ending of that ion was "ide." If it, however, ends in "ous" for the acid name, then the original ending of the ion was "ite." And if it ends in "ate," or sorry, if it ends in just regular "ic" without a hydro, then the original ending was "ate." So knowing these kind of pairs allows us then to figure out what the negatively charged ion was, and then we will make that formula with H plus. We always use H plus 1 as our cation in acid, so it will always start with an H. So a few examples I'm going to give you. So if we have, and I'm going to kind of change colors a little bit here, but if we have hydrochloric acid, and I'll always say the word acid at the end, the root word in there is chlor. So when we are kind of figuring out the original names here, we're going to keep that part of it. And then the hydro and the ic here tell us that we should revert the ending back to the original ending, which would have been ide, IDE in this case. And then once you determine that, you can say, okay, well, chloride ion is a Cl minus. And I know I'm going to mix this with the cation that is H plus 1. So hydrochloric acid, therefore, should have the formula, if I kind of crisscross or swap and drop these, of HCl. And that same pattern is going to be true here for when we look at the other versions. So if we have, sorry, wrong color. If we have chlorus, CHLOR, and then OUS, acid, the chlor is still the root word here, so that is going to come down. But the OUS tells me that the ending would have been ite. So OUS goes to ITE. And looking up what chloride is, I'm going to see that that's ClO2 minus 1. Again, our cation is always hydrogen. So these both have a 1 charge, giving us our acid formula of HClO and 2. Last example here, kind of going through all three possibilities, we would have chloric. And obviously we have very similar name to the first one that we did because both of these end in ic. The difference being the prefix of hydro being present in the first one, but not this one. So we still bring the chlor down here, but then it's going to go from ic back to its original ending, which was 8. And then looking up what chlorate is, very similar to before, but it's a ClO3. Mixing that with hydrogen, we get HClO3 as our acid formula. So this is how it will always work. You essentially need to pull out what the root is and put the original ending back to figure out what ion was present, and then just always mix and swap it with hydrogen as the cation. So looking at some of these examples here, I'm just gonna highlight what the endings are. So here we have ic. Here we also have ic, but we see this hydro. Here we have ic again, and then hydro and ic. So identifying that is important because now we can say, okay, if it is ic, it would have been 8. If it is hydroic, it would have been ide. Again, if it's just ic, it would have been 8. If it's again just ic, would have been 8, and then hydroic would have been ide. So in this case, we didn't have any examples that were the ITE version where it was OUS. There are some other ones on your worksheet, but we're going to just revert back to what it was. So nitric would have been nitrate, which is NO3 minus 1. Hydrocyanic would have been just cyanide, which is CN minus 1. Chloric, we did that example. That's ClO3 minus 1. Acetic would have been an acetate. So that's C2H3O2 minus 1. Kind of a lot going on there. And then hydrobromic would have been bromide, which is just Br minus 1. So in all of these cases, we're going to mix this with hydrogen as a cation. To make the correct formula. So for our formula here, these are both a 1 charge, so this just becomes HNO3 for nitric acid. These are both also a 1 charge, so HCN for hydrocyanic acid. We did this example, HClO3. This one is kind of crazy looking, but we do need to keep the H's separate because this is its own ion, so we would not write like H4. We have to kind of keep them separated into cation and anion pairs. And then HBr. Now, an example that I did not pull from the worksheet would be, what if my anion has a -2 charge? So we'll see that example kind of coming up next, but if this charge was not 1, then just like in ionic formulas, that subscript would transfer over to the hydrogen. So you might get H2, SO4, H3, PO4. So make your ionic formula for the acid like you would make any other version of ionic. These are just specific because they will always start with hydrogen. Okay, so this gets us to the opposite way. When we are having the formula, we're going to know it's an acid because it's going to start with hydrogen. So if the thing at the end ends in 8, we are going to need to change that ending to ic. If the thing at the end ends in ite, we will want to change that ending to OUS. And if it ends in ide, we're going to put the prefix of hydro and then the ending of ic. So one key here is that if we have a sulfur compound, we will put some vowels back. So we kind of need to add in some more of the original root word. So we'll see that when we get to our examples that I pick. Same thing will happen for phosphorus. We're going to need to put OR back for phosphorus. So instead of phosp, it'll be phosphor when we add these kind of endings on. And then you just write the word acid after you finish. So looking at our examples here. Let's say that we have these 3 acids. Notice, like I referred to before, the H has a 2 after it, and that's going to be because of the negatively charged ion. and what it would swap over to the hydrogen. So hydrogen would be +1. All of these are -2, which is why it's H2, unlike the examples we saw before. So the first thing to determine is, what is the name of this ion normally? So in this case, it is normally sulfide. This is normally sulfite. And this is normally sulfate. Again, we only hear about the negatively charged ion. The hydrogen tells us it's an acid, but the negatively charged thing is how we determine the name of that acid. So, what was the ending that was added based on the one that we want to get rid of? So we want to look at kind of the end here. We want to cross off the "ide," cross off the "ite," cross off the "ate," and change those based on our rules. So the "ide" tells us we're going to want hydro and ic. The "ite" tells us we're going to want OUS, and the "ate" tells us we're going to want just ic with no hydro. But as I said, instead of having it just be sulf, we have to add those extra letters back. So it becomes sulfur or sulfur. So instead of hydrosulfic, it becomes hydrosulfuric, adding these letters back. Same thing here. Instead of just having it be sulfus, it becomes sulfurous, adding those letters back. Again, same thing. Instead of sulfic, it becomes sulfuric, adding those letters back. And that's only for sulfur things and for phosphorus things. Everything else, you're kind of just using the original root as you see it once you cross off the ending. Okay, so after that, you just simply add the word acid at the end, and that is how you name acids. So we'll do a few examples here. We have ClO4. So again, important thing is to figure out what is the name of this ion normally. So this is normally perchlorate. This is normally phosphate. This is normally chloride. This is normally sulfate. And this is normally nitrite. So we want to look at what these endings are so we know kind of what we're changing. So perchlorate, 8 is going to go to ic, which means this will end up being still with this original part, perchlor, and then instead of 8 becomes ic, and then acid. No special extra letters added in that case. Here we have phosp, and then 8 goes to ic, so this becomes phos, PHOS, PH, but this is one of our exceptions, so we have to add this OR back in, and then ic. So instead of phosphic, it's phosphoric, and then acid. Here we have chloride. Ide goes to ic as well, but we have to add that hydro. So this becomes hydrochloric acid. Okay, sulfate, as we've seen, goes to ic. This is our other exception of extra letters. So sulf, but then add the UR, and then put the ic, and then acid. And then finally, nitrite. So ite goes to OUS. So this would be NITR, like normal, that root there, and then OUS. So it becomes nitrous acid. So that is essentially how we're going to name acids. It's all based on those kind of original 3 things that we saw of our memory cues, essentially. So knowing how it ends and what it changes to, you should be able to convert any acid to a name or any name to an acid.